Okay, so 9.7 is about taking the derivative in polar form. Okay, so we talked about a rectangular coordinate system. A rectangular coordinate system, your XY plane, is something that you guys talk about all the way from middle school. You learned how to plot a point, x, comma, y. Okay, so if we were seeing this, this would be some value x on some value y coming together to form our point x, comma, y. And if we follow the points up, notice it forms a rectangular. That is why it's called a rectangular coordinate system. For polar coordinate systems, you should have learned about these in pre-cal last year. And in order to find these ones, we know that with our rectangular coordinate system, the hypotenuse right here is represented by r. The angle that is formed from r and the x-axis is theta, and this is going to be a right triangle. So r is the distance from the origin to the point, so we could end up writing this point as r comma theta. Okay, and then theta is going to be the direction of the angle. So if we imagine this as our unit circle, since this length is going this way, if we were to go in this direction, theta would be positive. If we were to go in the opposite direction, theta would be negative. So that would be us drawing our r value in this direction. Okay. So again, you learned about polar coordinate system in pre-cal. You should have learned how to convert polar to rectangular and rectangular to polar. Out of these formulas, I would say these three are the most important. You need to make sure you have them memorized. Okay, more specifically that x is r cosine theta and y is r sine theta. Okay, so if you don't remember how they were found, remember this is a right triangle, and if we were to solve for theta, we could use SOHCAHTOA, the sine and cosine and tangent properties that you learned in geometry. So for example, we know that cosine of theta is equal to adjacent, which is x, over hypotenuse r. And so all they did was solve for x by multiplying both sides by r. So using that geometric property. Same thing with sine of theta. Sine of theta is opposite over reciprocal. So that would be, hypotenuse, so y over r. Okay, and again, they solved for y, got everything by themselves. This part right here, since r is representing the hypotenuse, we use the Pythagorean theorem to solve. So r squared is simply the sides squared and then added together, so x squared plus y squared. Okay, so using those concepts from pre-cal and geometry, we're going to answer the next three questions. And again, these questions are just review. So number one says r cosine theta is equal to -4. Okay, if we start with just looking at r cosine theta, we know that that's the same as x. So our answer here is just x equals 4. That's going from polar to rectangular. Remember, rectangular is only going to have things in terms of x and y, while polar will have r and theta. Okay, we can do the same thing with number 2. We see that this r cosine of theta is x, and then r squared is just x squared plus y squared. So based off of the formulas above. And so this is 4x is equal to x squared plus y squared. Okay, and then from here we know that this is not going to be a line like the first one, but instead a circle. Perfect. And so if I subtract 4x over, so I have this equation equal to 0, I have x squared minus 4x plus y squared is equal to 0. And in order to make this in proper notation, I would have to take these first two terms and use completing the square. When I do that, I'm going to end up adding 4 to both sides. And so I get x minus 2 squared plus y squared equals 4. And again, we use the properties of completing the square. To simplify this, if you need to refresh, I would go back and refresh on your own time. So then we have a circle with a radius of 2. And then lastly, number 3, we have 4 divided by 2 cosine theta minus sine theta is equal to r. So in order to get rid of the denominator, I'm going to multiply both sides by the denominator. So I have 4 is equal to 2r cosine theta minus r sine theta. So I just distribute the r in. And then from here, I see r cosine theta, which is x, and r sine theta, which is y. So we have 4 is equal to 2x minus y, which I can see is a linear function. So I'm just going to get y by itself, and I get y is equal to 2x minus 4. Okay, so these 3 are just to review. Again, if you're a little stuck on going between polar and rectangular, then I would look back at the material from last year in pre-cal. Okay. So now on to the calculus. It says a curve in polar form is given by r is equal to f of theta. Then in its rectangular coordinates are given by x is equal to f of theta cosine theta and y is equal to f theta sine theta. The derivative dy dx is defined the same way as a parametric equation. So when we did dy dx, we know that it is y prime over x prime. So that's what I'm going to write. So y prime of theta divided by x prime of theta. Okay, since they give us x and y, that's the same as just plugging in these equations. So f of theta sine theta, take the derivative. And then f of theta cosine of theta, take the derivative. Okay. So then from here, since we have two functions being multiplied together, we have f of theta and then on the top sine of theta, we're going to have to use the product rule to take the derivative. And so if you were to do the product rule, which is, it's kind of long, so I'm going to write it below, you would get f prime of theta sine theta plus f of theta cosine of theta. So again, that is using the f prime g plus fg prime divided by, and then we're doing the derivative for the next one. So this is f prime of theta cosine of theta minus f of theta times sine of theta. Okay, the easiest way to go about this is just to remember that it's always the derivative of y divided by the derivative of x. Okay, the rest is nice to know, but just remember every single time your function is going to change. So it's not like it's always going to be in this set where you have to always remember that it's f prime theta. Well, yes, they're going to give you that function. You just know that you take the derivative like usual and just use the product rule. I think it's just easier to remember this part. Okay. So looking at the first example, number 4. Okay, so at first, number 4 and number 5 are very common AP questions for both multiple choice and FRQ. You will, for some of them, have access to a calculator, so you'll have access to Desmos. That is more so in the next section of these notes, but there are some sections with this one that you would or could be given Desmos, just not guaranteed. That's why it's important we know our derivatives. So number 4 says, what is the slope of the line tangent to the polar curve r is equal to 1 plus 2 sine theta at theta equals 0? So what we're trying to find is dy dx. Okay, the derivative is the slope. And we know that this is y prime of theta, but theta is what value? 0. So y prime of 0 over x prime of 0. Okay, that is going to be the goal. That is what we're trying to find. So what I'm going to do first is I'm going to establish the equation for y. Well, remember on the first part of the notes, we said y is equal to f of theta times sine of theta, or r times sine theta. And we're given r here. So this is going to be equal to, and I'll just write it out, r sine theta. We are given r, so this is 1 plus 2 sine theta times sine theta. So I just plugged in r. Okay, then I'm going to simplify this, and I can do that by distributing sine theta inside. So y is equal to sine theta plus 2 sine squared theta. And then I can take the derivative. Okay, so taking the derivative of sine, I get cosine. And then taking the derivative of 2 sine squared theta, I would use the chain rule. So this becomes 4 sine theta cosine theta. And then from here, I want to find when y prime of theta is 0, or sorry, when theta is equal to 0. So I'm just going to plug in 0 for theta. So I have cosine of 0 plus 4 sine of 0 and then cosine of 0. This is going to give me 1 plus 4 times 0 times 1, because cosine of 0 is 1, sine of 0 is 0. And this gives me 1. So that is the first part of my answer. I know this is going to be 1 over some value. And I'm going to do the exact same thing for x. So x is equal to r cosine theta. So same thing, but now I'm multiplying by cosine. So I have x is equal to 1 plus 2 sine theta times cosine theta. And in this case, I wouldn't want to distribute the cosine inside, because I would end up with cosine, which is fine, but then I'd have sine times cosine. So I'd have to end up using the product rule regardless. So if I'm going to use the product rule, might as well just use it from this point. Okay, so I have my function, 1 plus 2 sine theta times cosine theta, my other function. So taking the derivative using the product rule, I have 2 cosine theta times cosine theta plus 1 plus 2 sine theta times negative sine theta. So again, using the product rule, f prime g plus fg prime. And then from here, I don't really need to simplify because I don't care about x prime in general. I just want to see the value of when I plug in 0. So x prime of 0 is equal to 2 cosine of 0 times cosine of 0 plus 1 plus 2 sine of 0 times negative sine of 0. Okay, this gives me 2 times 1 times 1. Okay, plus 1 plus 0 times 0, which means I get 2. Okay, 1 plus 0, 1, 1 times 0, 0, 2 times 1 times 1 is 2, which means I have dy dx equal to 1/2. And that's my answer. Okay, so since we are dealing with polar functions, we are going to always have some trig function in this, sine or cosine. Okay, so as long as you can remember to take your derivatives properly with those trig functions and to remember the product rule, it shouldn't be too bad. Any questions on 4? Okay, number 5 says find the values of theta where the polar graph r is equal to 1 minus sine theta on the interval from 0 to 2 pi has horizontal and vertical tangent lines. So the first thing we're going to do is horizontal. So in order for us to see if they have horizontal tangent lines, that means y prime has to equal 0. So first we establish what y is, and remember y is equal to r times sine of theta, And they give us r as 1 minus sine theta. So I have y is equal to 1 minus sine theta times sine theta. Okay, I'm going to then distribute sine inside, or you could use the product rule. Okay, the reason why I decide to distribute this is because when I do that, I don't have to use the product rule anymore. I'll just use the chain rule on that sine squared theta. Okay, then I'm going to take the derivative, and I get cosine of theta minus 2 sine theta cosine theta. Okay, so chain rule, I bring the 2 in the front, rewrite the function, and then take the derivative of sine, which is cosine. And then the next part I'm going to do is I'm going to see if I can take out a GCF. Okay, and that GCF I can take out would be what? Cosine. So I have 1 minus 2 sine theta. And then from here, I can set each of them separately equal to 0. So I can do cosine theta equals 0. So both of them can be set equal to 0. So I can have cosine of theta equals 0, and then 1 minus 2 sine of theta equals 0. And then I'm going to find all the values of theta that is going to make this true as long as it's between 0 and 2 pi. So for cosine theta equal to 0, that means theta is going to be pi halves and 3 pi halves. And then for the 1 minus 2 sine of theta, I want to get sine by itself. So I can actually subtract the 1 over, divide by negative 2. So this is asking, when is sine theta equal to 1/2? Okay. And that is when theta is equal to pi 6 and 5 pi 6. Okay, so that was for horizontal. We're going to go through the same process now for vertical. But for vertical, that means x prime is 0. Okay, so x prime is equal to 0. So x is equal to r cosine theta. We know r is 1 minus sine theta, and then multiply by cosine theta. So again, this would be, if I was to multiply cosine theta inside, I would still have to do the product rule regardless. So I'm just going to do the product rule right off the bat. So this is going to be x prime is equal to negative cosine theta times cosine theta plus 1 minus sine theta times negative sine theta. So again, that's using the f prime g plus fg prime. And then from here, I want to simplify it as much as I can. So this can be equal to negative cosine squared theta. And then I can distribute that negative sine theta inside 1 minus sine theta. And so I get negative sine theta plus sine squared theta. Okay. Then from here, I know that I can rewrite cosine squared theta as what? Who remembers the trig identities? 1. So 1 minus sine squared theta. But since we have that negative cosine squared theta, I can substitute this in and make this negative 1 plus sine squared theta. Okay, bring down the sine theta plus sine squared theta. Okay, simplifying this further, I now have sine squared theta twice. So this is 2 sine squared theta minus sine theta minus 1. Okay, which looks like what type of equation? Quadratic equation. So I would use, and I'm not going to show all these steps, but you would use u substitution, let u equal sine theta, and then you're going to be able to factor it, just like you would factor any quadratic. So this would be like 2x squared minus x minus 1. And what you would end up getting are these two factors here, 2 sine theta plus 1 times sine theta minus 1. Okay. And remember, we want this equal to 0, so we would set them each separately equal to 0. So I would have 2 sine theta plus 1 equals 0, and then sine theta minus 1 equals 0. And then in each of these, just get sine by itself. So in the first one, I would subtract 1, divide by 2. So this is sine theta is equal to negative 1/2. And the next one, I would just add the 1 over. So that sine theta is equal to 1. Okay. And then when solving for theta, I get 7 pi 6 and 11 pi 6. And solving for theta on the other one, I get pi halves. And so technically all the theta values that I got are going to be my answers for the horizontal and vertical tangent lines. However, notice that out of all those thetas, one of them repeats. Which one is it? Pi halves. So if pi halves, since it's repeating, we can't have a theta value be both vertical and horizontal tangent lines. Okay? So because of that, we cannot have them both be vertical and tangent. We just cross off those values, and those are no longer possible values. If you were to graph this, you would notice that at pi halves, we have a cusp. So if you look at the graph off to the side, this is where pi halves would be, and notice there is a cusp there. Can we take the derivative of a cusp? No, so that's why those values would not be included, which means my answers are just all the other ones left over. So 3 pi halves, pi 6, 5 pi 6, 7 pi 6, and 11 pi 6 for my vertical and horizontal.